would you mind telling everyone to go to this meeting?
Okay.
Here's the link.
Okay, Corinne would like to change our meeting, and so the number you should go to is 931-378-5400. And so give me a thumbs up if you heard me. Hold on, Christina. Yes. Repeat. The number? It is 931-378-5400. Live?
Yes.
Let's wait a minute until the stars are on. Are we on, ready to go?
Yes.
Okay, lights on. Hi, good evening. Welcome to Sommers Bausch Observatory. This is the special star party from the CU Stars. This is the Science, Technology, and Astronomy recruits. If you've had us visit your school or your community at some point, you may remind us for the people who come with things like the inflatable planetarium, black holes, exoplanets. And so tonight, because we can't actually get out and go visit you, we're inviting you into our observatory here, Sommers Bausch Observatory. We're on the campus of the University of Colorado in Boulder, and right now we have the lights on, which is not what astronomers usually do, but I wanted to walk you around our observing deck just for a moment and also introduce you to our observer for the night. There are only 2 of us on deck tonight because of social distancing, and we'll introduce you to a few more of the stars chiming in from a distance in a few minutes. So first, say hello. You can do.
Hello, my name is Karen Rowley. I am the student assistant here at Sommers Bausch Observatory, and tonight I will be helping you observe for the CU Star Party. This is our telescope. It's kind of big, but
let me give you just a view around from our observing console, the computer. Coming around, we have 2 20-inch telescopes. Here's one of them here. And keep going. And our second one, Artemis and Apollo, are the ones that we're using. Tonight we're only going to be using Artemis, just one telescope to get going. But it is a 20-inch diameter telescope, so it's a pretty fine telescope. We're hoping that we're going to be able to see some really beautiful things tonight. So before we go on a little farther, I want to see whether we can introduce you to a couple of the stars. So I'm going to mute myself and maybe ask if Philip could step in and say hello. So after Philip says hello, how about Noah? And Christina? And Katerina? Okay, so you've seen our team for tonight, and what we'd like to do now is turn off the lights and get, yes?
Yes, we can't hear. Just a second.
Okay, Corinne reminds me that I should let you see the dome and us one last time before we get on the sky. Okay, my Zoom just died, so off we go.
Okay, wait just a second. Can you try talking? Would you mind trying talking into the Zoom? No?
No, ask Philip or one of the stars.
No, I can hear you. Can you guys, okay, yeah, I think they should be able to hear us. Okay, never mind. Thank you. Okay, they can hear us.
Shall I get the lights?
Yes, please. On your first object?
Yep.
Okay. So, no, we should be able to. Unfortunately, as you can see here, Saturn and Jupiter has just set. So, Saturn and Jupiter has just set. So, I will, instead of pointing the telescope, I will be pulling up an example picture that I just took. Do you know what that means? Oh, okay, so they can hear me.
Yeah.
Okay. Yeah. So here is the picture of Jupiter. Unfortunately, we due to exposure reasons, because Jupiter is so bright, we can only take the Jupiter, or we can only take its moon. And tonight we decided to go for the moon. So here are the these stars, light specks are the moons, and I believe Katrina will be the one who will be talking to you about Jupiter's moon. So I'll hand it off to her now. Do you want me to?
Is everyone looking at this now?
Oh, just a second. Yeah, they can't hear.
They can't hear Corinne?
Yeah, they can't hear the Zoom.
The Zoom call?
It seems. Can you go upset me? We're sorry, technical difficulties.
Is she on mute? Go ahead and kill that window. So,
Can you, open up Seth's email again to see what this explanation?
open back to your YouTube.
Yeah. Oh, just, yeah.
Katarina, can you make sure that you are not muted?
Yeah, she's not muted, I could hear her. They can hear whatever we say. Would you like to do that, Erica?
I'd like to.
Use your phone.
Okay. So, Katarina, do you want to try again?
Oh, no.
No.
No. It's giving me. I'm so sorry. That's correct. don't understand this should be looking. Okay, thank you.
So, hey everybody, I'm so sorry we're having the usual unexpected technical glitches tonight. We appreciate you guys being on the chat, and so tell you what, if you send in a few questions about things that you want to look at, let us know as we're trying to figure it out. Our problem is that our stars audio is not coming through our system, and so, which is really terrible because they know everything you might actually need to know about things on the stars. So we're going to try to get rid of the echo. A few of the objects we might see tonight, they would include Jupiter. Jupiter has just down behind me, just set against the Flatiron Mountains. But we do have some pictures that Corinne took right before we opened up tonight. The same with Saturn. Alas, Saturn is just about to leave us. If you go out into the earlier evening, you will be able to see them. Jupiter's that incredibly bright thing off in the western sky. Saturn, nearby, a little bit fainter. Both of them, if you've got a good pair of binoculars, you can see some pretty amazing things like Saturn's rings and Jupiter's moons. So those are things to go out and look for yourself if you could get out from under a street light. Some of the other things we're hoping to show you a little later tonight are exploding stars, double stars, and possibly some galaxies as well as the evening wears on. And so again, we're hoping we can get the audio working on this, and if not, it may be down to me and Corinne. Fingers crossed we'll keep doing this. So let me look at the chat a little bit. Has the echo stopped for all of you guys? All right, you can see one of the stars here. He's listed under Sihu Yao. This is actually, we often call him Philip. He is one of our astrophysics majors here. And he is one of the guys who is working on black hole research here at the university. And so one of the things you can do if you wanted to, does anyone have a single question about black holes? Because we got a real expert here to answer. Like, why are black holes black? Okay, how big can black holes get? So Philip, you want to give an answer on that one? What's at the center? So you'll have to do it by answering on the chat. So Philip, if you can hear me, you're going to have to answer on the chat. There you go. You'll have to say what is a singularity. So if you can't see a black hole with your eyes, how do we know they're there?
should try going on. Seth is saying if it doesn't work, then quit Zoom entirely and start over again from the top.
Mm-hmm.
Should we try that?
Yeah, I think we can try that.
Huh?
I think we can try that.
Okay.
Let me say a few things.
Okay.
And see the YouTube chat, please. So we're going to try another moment of technological wonder here. If you guys will hold on just for a moment, we're going to keep the YouTube stream live. And I'm wondering, let's see what you've done there. Does anyone have any questions maybe about Jupiter? Because Katarina here has gotten all ready to teach you everything you need to know. So if you guys could maybe work a little bit more on the YouTube chat. Stars, we're going to kick you out of our separate Zoom session, and then bring you back, or ask you to come back in a couple of minutes, in about a minute. And so the stars will disappear just for a moment, but please still keep on asking and answering questions. Okay, you got that, Katerina? So you'll have to answer by typing into the chat for YouTube. Okay, go ahead and So stars, if you're listening, could you please come back in?
They're not on the call right now.
If they're listening on the YouTube.
Huh?
If they're listening on YouTube.
Oh, right.
So if you're listening on YouTube, go ahead and log into our previous Zoom, and we'll see if we can get you on audio this time.
I'm sorry.
Can you write into the stars,
What?
please? Would you write to the chat stars, please log in?
What?
Could you write into the YouTube chat stars,
Okay.
please log in? Or stars, please. Okay, I see the stars are coming back to us. Could somebody say something? We'll see if your audio comes through.
It's not coming through.
It's not coming through again? Okay, then I think we should have a change of technology here.
Okay.
I really liked how you guys were writing into the chat. And so let's turn off the lights. Let's actually go look at something in the sky, and we'll let you guys chat and be able to tell people about these objects that way.
Okay.
Does that sound good? Okay. So let's go to, what object should we go to next? Philip, you had the list. Jupiter? Well, we've seen Jupiter already, and Jupiter for real has set. So, okay, actually no, we still have the picture up. Katerina, do you want to talk a little bit more about Jupiter using the YouTube chat? How long has STARS been going on for? STARS has been going on for, I believe, 10 years. And so these guys, of course, have only been working on it from anywhere from 1 to 4 years. I've been here working with the STARS for about 10 years now. We've gone to more than 20 different schools all over Colorado. We've hit every single corner of Colorado, and we just keep doing it because we'd love to talk about astronomy. We love road trips. We like to come and visit you guys and, you know, bring whatever we can about the universe to y'all. So Cameron, where are you from?
So Katrina, in the chat is talking to you about the moons of Jupiter.
What's the next object?
What?
What's the next object? I'll tell you. What's next?
Oh.
So the next object that we'll be going to look at is Saturn. Did you take an image of Saturn? I think so. Right? So the next object that we'll be going to look at is Saturn. Did you take an image of Saturn? I think so. Right? So the next object that we'll be going to look at is Saturn.
Can you see the Pleiades right now?
Oh.
They can hear
I think people can hear us now.
Hear us. Can you see the Pleiades right now?
Now they can hear.
They can
Now
hear
they
us.
can
I think
hear
people can hear
the
us.
stream.
They can hear us.
The YouTube, the Zoom. I can't hear them is the problem.
Okay.
So,
People can hear us.
can you get on YouTube Zoom with your phone so that you can relay to me?
Okay.
So, thank you. Okay.
Can you remember one more time?
Oh, yes. You can relay to me. So, thank you. Okay. Okay.
It's been really
Oh, yes. You guys can hear the Zoom. Can you guys hear me? Okay.
It's been really
You guys can hear the Zoom. Can you guys hear me? Okay. Okay. Oh, okay. So maybe they can't hear me. Okay, got it. Oh, okay. So maybe they can't hear me. Thank you. Thank you very much, chat. Okay. So, unfortunately, I can't hear the Zoom. Yeah.
Thank you very much, chat.
I can't hear the Zoom, so
unfortunately,
Erica will be relaying back everything that you guys, the Zoom says to me. So,
And so the question we have, okay, Saturn makes next. Do we have an image of Saturn?
yes, we do have an image. So,
All right, let's bring up Saturn. And who's on deck to talk about Saturn? Saturn makes next. Do we have an image of Saturn?
yes, we do have an image.
All right, let's bring up Saturn. And who's on deck to talk about Saturn? Saturn makes next. Do we have an image of Saturn? All right, let's bring up Saturn. And who's on deck to talk about Saturn? Saturn makes next. All right, there we go. So this is very similar to what you'd see through our telescope tonight, Saturn and its rings. So there we go. So this is very similar to what you'd see through our telescope tonight, Saturn and its rings. So who's on?
Yes.
That would be me.
Very similar to what
So,
you'd see
this is
through our
Saturn.
telescope tonight,
It's well known for having some rather lovely ring systems going on. The rings are, contrary to what they might appear, they're not actually a ring, it's all material. They're actually made of small rocks and ice that are orbited around the planet. Fun fact about Saturn, it's the slowest moving planet that can be seen in the naked eye. And so it was named after the Roman god Saturn. It has also many moons, 53 names named after the Roman god, and like Jupiter is a gas. It has also many moons, 53 names named after the Roman god, and like Jupiter is a gas. It has also many moons, 53 names named after the Roman god, and like Jupiter is a gas. It has also
Saturn is really pretty.
Hey, apparently there's an echo.
Yeah, that's what they're saying in the chat.
Yeah.
Saturn is really pretty.
Maybe turn off SBO. Hey, apparently there's an echo.
Yeah, that's what they're saying in the chat.
Yeah.
Saturn is really pretty.
Maybe turn off SBO. Hey, apparently there's an echo.
Yeah, that's what they're saying in the chat.
Yeah.
Saturn is really pretty.
Maybe turn off SBO. Hey, apparently there's an echo.
Yeah, that's what they're saying in the chat.
Yeah.
Saturn is really pretty.
Maybe turn off SBO. Hey, apparently there's an echo.
Yeah, that's what they're saying in the chat.
Yeah.
Saturn is really pretty.
Maybe turn off SBO. Hey, apparently there's an echo.
Yeah. are you wanting us to talk and see if there's an echo?
Check again. Is there an echo? Oh, we're good now?
Cool, perfect.
All right, perfect. Any questions about Saturn?
So Saturn is one of 7 objects that people used to be able to see up in the sky with the naked eye. And it's not a coincidence, as a matter of fact, that there are 7 visible objects with the naked eye, and there are 7 days of the week. Originally, the 7 days of the week were named after those 7 objects. And some of the names got changed later. Our current, in English, it doesn't really match up anymore because we borrowed some from Norse mythology. But if you look at like Spanish or French, you can see that similarity between the objects and the days of the week. I'm seeing a question about how many rings there are. Again, the rings are not actually like defined rings. Those gaps that you see in this disk of material comes from some larger objects that have gravitationally cleared a space in between, like in this disk of material. I don't know how many gaps there are off the top of my head, but the reason the rings look flat has to do with how things collide and interact in a spinning disk. So because of these collisions and these gravitational interactions, things that are going around an object tend to collapse into a disk. It's a similar process that causes our solar system to have a disk-like appearance to it. So there are 53 named moons. There are many other moons that haven't been named or haven't been confirmed yet. They keep finding new moons for gas giants because now that we're able to get up close and see them, we're able to see a lot of objects that we just weren't able to see before.
Yeah, can you hear me? People in the chat hear me? Okay, good. So I'll talk about Mars a bit. So it's the fourth planet from the sun, second smallest planet after Mercury. It's named after the Roman god of war. It has two moons, Phobos and Deimos. It's red due to iron oxides that covered surface, which is basically similar to rust here on Earth. Um, Mars has massive dust storms that can almost cover the whole entire planet. We sent a couple of rovers. I'm sure you know about those. We have Sojourner, Spirit, Opportunity, Curiosity. Curiosity is still going strong, and we believe that Mars once had running water on it, but that's all gone now, and there's only water basically at the poles and ice. And any questions? Yeah, Mars is the red planet because of that red dust, the iron oxides that cover the surface. It's also really bright because back in October, it was actually at its closest point to Earth, so that's why it's so bright right now. Yeah, any more questions on Mars before we head to a nebula? On the new rover, I'm not exactly sure when it's supposed to land. I think it launched recently. The SpaceX mission to Mars, I think it's pretty optimistic to get there, I think by what, 2024? But hopefully, I'm thinking like 2030, they might be able to get maybe some humans there. Martians, so probably no Martians, but there could have been life when there was running water, so we may find evidence of like microorganisms, stuff like that, if we explore a bit deeper on the planet. Oh, Pluto. That's a long story, but sadly, Pluto's not a planet anymore. It should still be a planet basically, but it's technically a dwarf planet. But I still think it should be a planet because it's pretty cool. Yeah, Pluto's the far one.
Hi everyone, I'll be talking about the Dumbbell Nebula. Can you hear me? Great. So the Dumbbell Nebula looks really like an apple core. So it's also called the Apple Core Nebula. It's a planetary nebula, but it's not a planet. It's about it's about 1,000 light years from Earth, and it was the first planetary nebula to be discovered by Messier in 1764. That's why it's also called M27. So for a planetary nebula, at its center is a white dwarf. So when our sun dies, it will also become a planetary nebula, leaving a white dwarf at the center. So the white dwarf is actually not very big. It's very compact objects like the black hole that I study. A white dwarf is made up of by many electrons. It has a size about 5% of our sun size. And its mass, however, is very massive. It's about half the mass of the sun. So this planetary nebula will perhaps be the dimmest objects that we'll be observing tonight, and you can see its shape. It's very, very gorgeous. Many planetary nebulas are very gorgeous, and it has different colors. If you Google M27 Dumbbell Nebula, which makes it looks really like an apple core. Yes, planetary nebulas are not does not make any planets or stars. You're correct. I think why they're named planetary nebula is that they're as pretty as planets, I assume. So planets are created when a nebula, like a nest, like a nebula containing primary stars, and when that collapses, creates many stars, and the gases surrounding the stars will create planets. For example, when the solar system was created, it was created from the solar nebula, and at that time, Jupiter and the Sun was both trying to be stars, but Jupiter couldn't eat as much stuff as the Sun did, so the Sun became the sole star in our solar system. We're moving to a star cluster called Pleiades. If you have a Subaru car, I believe that the logo of Subaru is Pleiades. Pleiades is definitely one of my favorite star clusters and deep sky objects, just because it's so easy to see with naked eyes. You can just see it in Taurus. And it's very, very gorgeous just by using a binocular to look at it. We're taking an exposure of Pleiades right now. That means opening our shutter for a long period of time, allowing light to come in. So the Pleiades cluster is also called the Seven Sisters cluster because there are seven visible stars, and Karine is trying to get a better image of Pleiades. If you go out and you look at the night sky right now, you should probably be able to find Pleiades in Taurus. It's also called Messier 45. It's also in the Messier catalogs. It's an open star cluster containing middle-aged hot B-type stars, meaning these stars are very, very hot. They are very blue and they're very bright. So these stars are very young compared to our sun. They're formed within about 100 million years compared to our sun's age at about 4 billion years. And it is in the northwest part of the constellation Taurus, the bull, and it's among the star clusters nearest to Earth. Astronomers estimate that this cluster will be able to last for about another 250 million years more before dispersing due to gravitational interactions. And the person who first discovered Pleiades was Galileo. Caterina introduced the moons of Jupiter. They're named the Galilean moons because Galileo was the first to discover them. And Galileo was also the first astronomer to observe Pleiades through a telescope. I believe he's not the one discovering it, but he's the first one to observe it using a telescope. He also published his observations with a sketch of its 36 stars, letting people know there's more than what we used to call it the seven sister cluster. There are more stars in the star cluster. And in fact, it is true for many, many star clusters that it will contain many more stars than what we can see with naked eyes. And our next target will be N15.
All right, so we just put up a picture of M15, and this is a globular cluster. So what's different? So an open cluster, it's a lot younger and it has a lot less stars than a globular. Globulars are a lot denser, they're a lot older. Yeah, there's a good picture. That looks really good. Yeah, so they're super dense. It's home to about 100,000 stars, and it's about 360,000 times brighter than our sun. It stretches across 175 light years. And and in the middle, it's undergone something called core collapse. So the center is really, really densely packed with stars. And they also think there might be a black hole in the center. So, any questions about it? So you usually find clusters like these in the halo of a galaxy. So Earth, our sun, and open clusters usually find in the disk, which is like the spirals you usually see when you see a picture of a galaxy. But there's also a bunch of objects that kind of float around, orbit around the center in kind of a sphere around the galaxy. And that's where you find a lot of these globular clusters. So yeah, so this would basically look like a star to the naked eye. Um, but so far away, it's pretty hard to see. So, but when you have a good telescope, you can resolve all the stars that you can find in the cluster. Yeah, okay, so core collapse, you have a lot of stars that come together. And when that happens, you get a lot of mass in a really small space, and that usually creates a black hole. Um, you can also take measurements about how the orbits look, how the stars in the cluster orbit around the center, and that can tell you the mass of the object. And that can give you a clue to if it's a black hole or not. So. Maybe not change in measured light. It's definitely more you'd look at the orbits of the stars around it, so you can figure out the mass and how big it is, basically. All right, now we have a picture of Andromeda up.
Yes, so I'm going to talk more about Andromeda. Andromeda is a galaxy, so it's very different from everything we just saw. We saw tonight. Everything we have seen are objects that are within our Milky Way galaxy, like planets, star clusters, and nebula. They're all within our Milky Way galaxy. But you can see Andromeda here. It is a galaxy that's outside of our Milky Way galaxy. It is approximately 2.5 million light years away from us. That means light from Andromeda travels 2.5 million years from the galaxy to us. And it is very, very big. It's about 200,000 light years across. And we think that Andromeda, we deduce that Andromeda galaxy will collide with our Milky Way galaxy in about 4.5 billion years, like the age of our sun right now. So when the two galaxies merge together, we'll see very, very bright night skies. It will form a giant elliptical galaxy, and we'll see very interesting interactions between between the supermassive black holes and its surrounding materials around the supermassive black hole when they interact. And an estimate saying how many stars in the Andromeda galaxy is about 1 trillion stars. That's many, many stars. And at the center of the Andromeda galaxy, like almost every galaxy, there is a supermassive black hole that is much bigger than the supermassive black hole in our Milky Way galaxy. Is there any questions regarding Andromeda? Yes, Noah has answered the question that black holes do not suck stuff in. Black hole has a accretion disk, many of them, that things spiral in towards the black hole when when part of their angular momentum, part of their rotational energy is converted into it's released, and they falls into a lower orbit and gradually spiral into a black hole. We will be moving to Uranus next.
All right, so I believe this would be a picture of Uranus. What makes Uranus really unique is it is actually flipped on its side. So while all the other planets in our solar system are orbiting or rotating this way, Uranus is actually on its side. So it's rotating horizontally instead of vertically. Another interesting thing is Uranus and Venus are the only two planets to be orbiting the sun in the opposite direction as, to be rotating on their axis in the opposite direction as the other planets. Uranus has a very distinctive blue color, which comes from its methane gas in its atmosphere. And it actually also has a ring system. Although we can't see it, all the gas giants do have some sort of ring system. It's just not as good as Saturn's. Uranus also has a lot of moons. We know of 27 of them. Does anyone have any questions about Uranus? Huh?
All right, everybody. So we've come to the end of, let's see if I can find a little bit of light. We've come to the end of our evening here, and I'd like to thank everybody for coming to Sommers Bausch Observatory to come and see our telescopes and come and see some of the things we can see through our telescopes. I wanted to invite all of you from your schools to keep on thinking about the stars, talk to your teachers. Maybe we can arrange for our group to come back to you and visit your school at some point. We can bring black holes, we can bring planets around other stars, we can bring our own telescopes to come and observe with you. If you're a student from CU or a friend in the family, definitely keep an eye. We may be doing another virtual star party soon. I want to give a special shout out to any space miners from the CU campus. First of all, congratulations for being a miner. But on top of that, if you're interested in getting in touch with CU stars, what you can do is contact Sommers Bausch Observatory or go to the website for the Astrophysical and Planetary Sciences Department. Look under undergraduates and you'll see our website and our contact information as well. So from the dark here at Sommers Bausch Observatory, I want to say have a great night. I hope you enjoyed everything the CU stars have been telling you about the universe, and we hope we might be able to do this again soon. So thank you, everybody.
No, just